Tell me about a time you had to push back on a requirement introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand how you handle unrealistic or risky requirements, how you communicate with product owners or business teams, how you explain technical trade-offs clearly, how you avoid saying no without offering options, how you protect system quality, security, and maintainability, how you manage scope and delivery, expectations, how you keep the relationship professional while disagreeing. This question is especially important for Java developers, backend developers, Spring Boot developers, full-stack developers, senior software developers, team leads, Agile teams, system design interviews. The best way to answer this question is by using the STAR method. STAR means S, situation, explain the background. T, task, explain your responsibility. A, action, explain what you personally did. R, result, explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you pushed back respectfully, explain the risk, and offered a practical alternative. Question: tell me about a time you had to push back on a requirement. Example 1. Pushing back on returning all records from an API situation. In one project, the product owner requested a customer search API that returned all matching records in one response. From the business side, this sounded convenient because users could see everything at once. However, the data volume was large and would continue to grow. Task: I was responsible for designing the API and explaining why returning all records would create performance and scalability risks. Action: I first listened to the product owner's goal. They wanted users to find customer records quickly and avoid missing results. Then I explained the risk in simple terms. If the API returned thousands of records at once, the page could load slowly, the database would work harder, the browser could become slow, network response size would increase, peak traffic could affect other users, production performance could become unpredictable. I avoided saying only, "We cannot do that." Instead, I proposed a better alternative. I recommended: check pagination, check maximum page size, check sorting, filters, total record count, check clear empty result response. I also showed a sample response format with page number, page size, total records, and result list. This allowed users to access all records page by page while keeping the system fast. Result: the product owner agreed to use pagination. The API was released with better performance and scalability. The users could still access the data, but the system avoided unnecessary load. Why this answer works? This answer is strong because it shows professional pushback, performance awareness, API design, business-friendly explanation, alternative solution. Example 2. Pushing back on skipping backend authorization situation. In one project, the business wanted to release an admin feature quickly. The front end already hid the admin screen from normal users, so someone suggested that backend authorization could be added later. Task: I had to push back because the API controlled sensitive configuration and backend authorization was required before release. Action: I explained the risk calmly and clearly. I said that hiding a button or screen in the front end improves the user experience, but it is not enough for security. A user could still call the backend API directly if the backend did not enforce permission checks. I explained the possible impact. COC unauthorized configuration changes, COC production behavior changes, COC audit issues, COC security review failure, COC supporting compliance risk. Then I proposed the minimum secure version for release. The API needed: check authentication check, admin role authorization, service layer permission check, audit logging, unauthorized and forbidden responses, tests for admin and non-admin users. I also suggested reducing scope in another area if the timeline was tight, but not removing security controls. Result: the team agreed that backend authorization was required before release. We implemented the admin role check and audit logging. The feature was released securely, and the same pattern was reused for future admin APIs. Why this answer works? This answer is good because it shows security pushback / backend authorization knowledge, risk communication, minimum secure release thinking, audit awareness, strong engineering judgment. Example 3. Pushing back on real-time reporting situation. In one project, the business team requested a report that showed real-time data every time users opened the page. The report involved large data calculations across many records. Task: I needed to explain why real-time reporting could create performance risk and propose a practical alternative. Action: I first asked why real-time data was needed. After discussion, I learned that users needed accurate daily reporting, but they did not need second-by-second updates. Then I explained the risk. Real-time calculation would mean the system had to process a large amount of data every time a user opened the report. This could cause KIRK, slow report loading, KIRK, high database load, KIRK, timeout risk, KIRK, poor user experience, KIRK, impact on other application features. I proposed a scheduled report generation approach. The report could be generated once per day or every hour depending on business need. The benefits were faster report loading, lower database load, predictable processing, easier monitoring, more stable user experience. I also suggested showing the report's last refresh time so users understood how current the data was. Result: the business team agreed that scheduled refresh met the real business need. The report was faster and more reliable. We avoided building an expensive real-time solution that was not actually required. Why this answer works? This answer is strong because it shows business requirement analysis, performance risk explanation, stakeholder communication, practical alternative, avoiding over-engineering, user experience awareness. Example 4. Pushing back on adding too much scope to a sprint situation. In one sprint, the product owner wanted to add extra dashboard features after sprint planning had already completed. The new items included export functionality, additional filters, and a detailed drill-down page. Task: I needed to push back on adding all the extra scope because it could risk the sprint goal and reduce testing time. Action: I first acknowledged that the requested features were valuable. Then I explained the impact of adding them mid-sprint. The additional work would affect backend API changes, UI changes, database queries, QA test scenarios, regression testing, sprint timeline, release confidence. Instead of saying no, I suggested prioritizing. We split the features into must-have and next phase items. The current sprint would include track, required summary cards, basic filters, role-based visibility, backend API changes, validation, tests. The next sprint would include export option, advanced filters, drill down page. I explained that this approach delivered the highest business value without putting quality at risk. Result: the product owner agreed to reduce the sprint scope. The team delivered the core dashboard features on time. The remaining features were planned properly for the next sprint. Why this answer works? This answer is good because it shows scope management, agile communication, delivery risk awareness, prioritization, MVP thinking, protecting quality. Example 5. Pushing back on a risky quick fix situation. During a production issue, an API was failing for a small group of users. One suggested requirement was to bypass a validation rule temporarily so users could continue submitting requests. Task: I needed to push back because bypassing validation could allow bad data into the system. Action: I first acknowledged the urgency. The business needed users unblocked quickly. Then, I explained the risk of bypassing validation completely. It could create invalid database records, downstream processing errors, reporting inaccuracies, manual cleanup work, future production issues. I proposed a safer quick fix. After reviewing failed requests, we found that the issue happened only when one optional field was missing. Instead of disabling validation, we added narrow handling for that optional field. The fix included null safe handling, clear validation rule, unit test for missing optional field, regression test for normal validation, QA verification, follow-up cleanup task. Result: the production issue was resolved quickly. We avoided introducing bad data. The team later improved the validation logic more cleanly. Why this answer works? This answer is strong because it shows pushback under pressure, production judgment, risk management, safe compromise, data quality awareness, long-term ownership. Example 6. Pushing back on storing sensitive data unnecessarily situation. In one project, a requirement suggested storing full customer details locally in our service for convenience. The service only needed a small subset of those fields to complete its work. Task: I needed to push back because storing unnecessary sensitive data increased privacy and security risk. I reviewed the actual business use case. The service only needed customer ID, customer status, eligibility flag, timestamp of verification. It did not need full customer profile details. I explained the principle of data minimization in simple terms. I said we should store only what we need for the feature and avoid keeping extra sensitive information. I explained the risks of storing unnecessary data. Higher privacy risk. Larger impact if data is exposed. More audit responsibility. More cleanup work. More compliance concerns. I proposed calling the customer service when needed and storing only the minimal required fields. I also suggested audit logging for access. Result: the requirement was adjusted. We stored only the necessary fields. The design reduced security and privacy risk while still meeting the business need. Why this answer works? This answer is good because it shows data privacy awareness, least privilege thinking, secure design, stakeholder communication, practical alternative, business need alignment. Example 7. Pushing back on building a full microservice too early situation. In one project, a new feature was being discussed, and someone suggested creating a new microservice immediately. The feature was still small, and the business rules were not stable yet. Task: I needed to push back on creating a new microservice too early, because it could add unnecessary complexity. Action: I first acknowledged the reason behind the idea. A separate microservice could provide independent deployment and clear ownership later. But I explained that at the current stage, the boundaries were not clear enough. Creating a microservice too early would introduce separate deployment pipeline, service-to-service communication, monitoring overhead, data ownership decisions, failure handling, testing complexity, operational support. I proposed an incremental approach. First, we could implement the feature as a clearly separated module inside the existing service. The module would still have clear package structure, service layer boundary, separate validation logic, separate DTOs, tests, documentation. If the feature grew and boundaries became clear, we could extract it into a microservice later. Result: the team agreed to start with a modular design instead of a new microservice. The feature was delivered faster with less operational complexity. Later, if needed, the clean module boundary made future extraction easier. Why this answer works? This answer is strong because it shows architecture pushback, avoiding premature microservices, incremental design, operational awareness, scalability thinking, practical engineering judgment. Example 8. Pushing back on releasing without enough testing. In one release, the business wanted to release a feature quickly because the deadline was approaching. The development work was mostly complete, but QA had not finished regression testing. The feature touched a shared validation component used by multiple APIs. Task: I needed to push back on releasing without enough testing because the change could affect other flows. Action: I explained that the change looked small, but the component was shared. If there was a mistake, it could impact multiple APIs, not only the new feature. I explained the risk in simple terms. If we change a shared rule, every flow using that rule may be affected, so we need to test the related flows before release. I suggested focused regression testing instead of delaying everything indefinitely. The focused regression checklist included capital original feature happy path, capital original feature validation errors, capital older APIs using the same validator, capital role-based access, capital error response format, capital edge cases. I also helped QA identify the impacted APIs so testing could be efficient. Result: the team agreed to complete focused regression testing before release. QA found one issue in an older API that used the shared validator differently. We fixed it before production. The release went out safely. Why this answer works? This answer is good because it shows quality pushback, regression risk awareness, shared component understanding, QA collaboration, practical compromise, release safety. Best short answer version. If you need a short interview answer, you can say, in one project, the product owner requested a customer search API that returned all matching records in one response. From the business side, this seemed convenient because users could see everything at once. I pushed back because the data volume was large and would continue to grow. I explained that returning thousands of records at once could make the page slow, increase database load, slow down the browser, and create performance issues during peak traffic. Instead of simply saying no, I proposed pagination with a maximum page size, sorting, filters, and total record count. I showed a sample API response so the product owner could see that users would still be able to access all records page by page. As a result, the product owner agreed to the paginated design. The API was released with better performance and scalability, while still meeting the business need. Common mistakes to avoid. 1. Saying only no. Bad answer. I told them we could not do that. Better answer. I explained the risk and proposed a safer alternative. 2. Sounding negative. Bad answer. That requirement was bad. Better answer. The requirement had a valid business goal, but the proposed approach had technical risk. 3. Using too much jargon. Bad answer. The query execution plan and serialization overhead would cause latency issues. Better answer. Returning too much data at once would make the page slower for users. 4. No alternative. Bad answer. I pushed back because it was risky. Better answer. I suggested pagination, filters, and maximum page size as a safer solution. 5. Ignoring business need. Bad answer. We should not build it that way because engineering does not like it. Better answer. I first understood the business goal, then proposed a solution that met the goal with less risk. Best practices for answering this question. Use the STAR method. Explain the requirement clearly. Acknowledge the business goal. Explain the risk respectfully. Avoid blaming stakeholders. Use simple language. Provide options. Recommend a safer alternative. Show collaboration. End with a positive result. What interviewers are looking for. Interviewers want to see whether you can push back professionally, protect quality and reliability, communicate risk clearly, understand business goals, avoid unnecessary conflict, provide practical alternatives, influence decisions respectfully, balance delivery and long-term design. For senior roles, they also want to see technical judgment, stakeholder management, architecture maturity, security awareness, production readiness thinking, scope control, leadership through communication. Strong words to use in your answer. You can use words like clarified, explained, challenged respectfully, pushed back, proposed an alternative, aligned, recommended, reduced risk, protected quality, balanced, prioritized, negotiated, documented. Example: I pushed back respectfully by first understanding the business goal, then explaining the technical risk in simple terms, and finally proposing a safer alternative that still met the requirement. Good requirement pushback topics you can use. Depending on your experience, you can talk about returning all records instead of pagination, skipping backend authorization, real-time reporting requirement, adding too much scope mid-sprint, risky quick production fix, storing unnecessary sensitive data, creating a microservice too early, releasing without enough regression testing, save time, skipping audit logging, ignoring error handling, building custom solution instead of using existing pattern, adding caching without checking data freshness, accepting unclear requirements, deploying late without support coverage. Final summary. Tell me about a time you had to push back on a requirement is an important interview question because software developers must balance business goals with technical quality, security, performance, and maintainability. The best answer should include: check what requirement you pushed back on, why the requirement had risk, how you understood the business goal, how you explained the risk, what alternative you proposed, how stakeholders responded, what result improved. Good examples include pagination instead of returning all records, backend authorization before release, scheduled reporting instead of real-time reporting, scope reduction during sprint, safe quick fix instead of bypassing validation, data minimization, modular design instead of premature microservice, focused regression testing before release. The strongest answers show professional communication, business understanding, technical judgment, practical alternatives, and positive stakeholder alignment.